Hello, everyone. Thank you for joining our Cloud Security Masterclass series, where we're all about empowering engineers to take command of cloud security. I'm Drew Wright, and I hope you're doing well. We had originally done this session live with an interactive audience, but we experienced enough internet connectivity issues that we decided it would be best to just re-record it and get that out to everybody. But we will make sure that we cover the questions that were asked in that session. Before I turn it over to my colleague Josh to get started, I just got a couple quick public service announcements. If you've seen Josh run one of his cloud misconfiguration exploit simulations, you're really going to love our upcoming Cloud Security Masterclass session, Thinking Like a Hacker. We're going to put the bad guy hat on and look at our cloud security posture from a whole new perspective. It's going to be a lot of fun. We have a growing library of Cloud Security Masterclass content available to you on demand. You can access that at fugue.co/masterclass. So check that out. And we also just released the first edition of the Engineer's Handbook on Cloud Security. This is a PDF reference. It's jam-packed with useful information to help you get your cloud secure and keep it that way. You can get that at fugue.co/handbook. All right, so let's get on with the session. Hey, Josh, you there?
Hey, Drew, I am here.
Awesome.
And for anyone who's watching this, as Drew said, we normally like to make these super interactive, but we just had connectivity issues, so we're going to re-record it to give you, something to refer back to. We'd still love to do an interactive one where you bring us live your IAM dilemmas and we work them through with you a little bit in front of the world. So if there's interest, we'll do that. So let us know. Also, for the Thinking Like a Hacker session, I've got an idea of what exploit I'm going to show you how to do. But if there are things you want to see from the news, I'm planning on doing a exposed credentials hack and ways to exploit that and to defend against it. But if there's other things that you're really curious about, something from the news, something you've thought about, run it by us, because we like these things to be really dynamic. So keep that in mind and just let us know. All right. So the Masterclass series is really about us trying to share with you how to think about these problems and own them. It's not really a recipe book. It's more like learning how to be a good cook, right? And a good cook doesn't always need a recipe. You learn from the recipe, but then you make your own. So what we're going to try to do in every episode of this series is get you thinking in a way where you can fully control your own destiny based on good knowledge of the problem space. And therefore, we're going to talk about mental models, we're going to talk about processes, and yeah, we're going to use examples and show you detailed specifics. But those are really just the illustrations in the text, okay? So we're going to set the table a little today on IAM and how to think about it. Again, that mental model, a process you can use to own your IAM and be successful and secure at it. And then we're going to do a deeper dive. And we actually, when we did the live session with the connectivity issues, we did get some cool questions and we saved those. So Drew is going to play the audience here and ask me some questions along the way and at the end to simulate all you good folks who were here before. All right, a little bit about context in cloud security. This is how we at Fugue, and prior to Drew and I founding Fugue, I was at AWS, working in national security kinds of environments. This is really how we think about cloud security. So this is the context in which we're trying to hold these master classes to get you up this mountain of cloud security. So what we call Basecamp 1 is discovery and posture reporting. That's just knowing what you have and knowing if you have vulnerabilities, being aware. That's actually a much bigger and harder problem than folks realize, and it's absolutely critical, and it's a good starting place. Basecamp 2 is about configuration change control. So establishing configuration baselines, detecting and reporting on movement of things and whether those are dangerous things, the ability to then respond to those with remediations, et cetera. And then as you go up the mountain to base camp 3 and the peak, you're really talking about getting automation in place, first integrated into your CI/CD pipelines and so on, and then finally truly automated self-healing cloud security. And we do all this stuff at Fugue. This masterclass is really focused on base camps 1 and 2. Okay, most folks are still trying to figure out if what they have is safe, and even knowing what they have, and then making sure changes are safe changes, are good changes. So we're going to help you with those 2 today, in that you'll be able to, at the end of this lesson, I hope, go back and examine what you have in IAM and have a better sense of whether it's safe and secure. And then as you add new policies or role associations or whatever you're doing with IAM, whether those things are good and safe configuration. So we're not going to focus on those upper tiers there today, although everything we're doing applies to those. Okay, but you got to start kind of manual before you get to the full automation. You have to know what's safe and secure, and that's our focus today for IAM. So why are we focusing on advanced IAM misconfiguration in particular? Because it is probably one of the least understood and most dangerous, if done improperly, services in AWS. It can be very secure, but it is a bit of an enigma to many people. So many advanced IAM misconfigurations that hackers know how to exploit are not recognized by things like CIS and NIST or the IAM usage analyzer that AWS has as problems. Many of the juicy configurations that hackers want, those things think are okay. And therefore, they're not recognized as vulnerabilities. And therefore, they're really easy to overlook, right? And as a result of all that, most people have them in their accounts. They're very common. And you'll see in most major breaches, identity, either using identity in the form of, like, found credentials, that's the most obvious and kind of pedantic one, but also things like using IAM as a network outside of the TCP/IP network to get across service boundaries that in the past, in the pre-cloud era, you would have thought of from a TCP/IP networking perspective, which is irrelevant if you're hacking IAM like a network. So they get used in a lot of breaches because the bad guys are often ahead of the good guys on that. All right, yeah, I just mentioned this. AWS IAM is more than just an identity and access management service, because it is used for the identities and access management of components of your cloud talking to each other. It's really a cloud native network that goes around the traditional network, right? So if I grant IAM permissions to, allowances, if you will, through a policy to a compute instance, whether that's EC2 or a container or Lambda, if it's operating using IAM as its access control mechanism, it's hitting the cloud API. Depending on the cloud API, that may or may not be going through your network boundary at all. So it really does act as an overlay network, which in many cases is outside of your TCP/IP based virtual network. That should make you worried. That should concern you. It's really powerful, and done well, it's much safer. But done poorly, you can open vectors that you aren't even imagining, and none of your SIM tools or anything like that are catching. All right, so let's dive in a little bit. I'm going to go. Oh, good job, Josh. I'm going to go out of PowerPoint, yay, and into a blank whiteboard. So the first thing I want to do is give you a mental model so you can start to get your head around what IAM is in context, right? And I think that when I've looked at the AWS docs, the docs are quite good, but they're also kind of so accurate as to be data more than information. So what I'm going to try to do here is give you a simple way to think about this that's accurate, that allows you a kind of taxonomy of how to think about this problem. So the first thing is IAM is just a collection of policies applied to stuff. There are different kinds of AWS policies. IAM is one of them, okay? But really what we're talking about is evaluation of policy against particular actions, against particular resources from principles. So this is true of all of AWS. So I'm going to make 3 columns here. Over here on the left, I'm going to say principles. And I'm going to use the right spelling of principle this time. Yeah. And let's just draw a line there. And then I'm going to draw this big vertical line. Oop. My computer's getting away from me, and I didn't want that little diagonal there. Let's get rid of that. And this is, I'll explain in a moment. So now I'm going to say resources. So we have principles. You know what? I just got that backwards. Principles, then actions. Then resources, okay? Now you will see these terms throughout the AWS docs, and they're really, really important fundamental concepts to understand. So a principal is something like a user, okay? It is, let's just label that. A principal is an actor. And you might be thinking of that as like your developers and your admins and operators. That's all true. But it's also things like processes. And by process, I mean something like the program running on an EC2 instance or the program running in a Lambda function. But these are things that initiate actions against the cloud APIs. Actions are the list of actions the AWS API provides, right? So these can be very, very extensive in services like EC2. There are over 400 actions. Things like, you know, creating a new EC2 instance or mounting an EBS volume, etc. In S3, they're also quite lengthy. Things like getting an object, listing the contents of a bucket. But what I want you to think about here, just to simplify your world so that you can get your head around it, is all AWS has are actions. There are some exceptions to that, but they're edge cases. Don't worry about it. So you got a principle and you have a list of actions. So we'll just put some little dots here for actions. And I'll show you where you can find all these things. In fact, why don't I jump over and show you some actions right now. We'll grab some AWS documentation. Come on, Zoom, get out of my way. All right, so here I'm just going to some of the AWS docs. And so these are EC2 actions. Now, EC2 is kind of the pathological case of massive quantities of actions. And the reason is it's one of the oldest services. It's one of the most powerful services. But you can see here, we've got a long list of actions. Another place you can find this, and maybe a little easier to navigate in some ways, is to just go to the IAM console and go ahead and create a policy. Whether or not you're going to use it, this can be a learning exercise. So I'm going to choose a service. We'll say EC2. There we go. And now it's going to list all the actions for me. So what if I say all actions? Don't ever do that. There's the built-in admin role, and we'll get to that in a second. But if you're creating roles, that's almost always a terrible decision. So let's just take a look through some of these. So you can see even in list for EC2, oh, let me get my cursor highlighter up. Okay, you can see here, even in list for EC2, describe account attributes. If I just select all on this, come on, you. Yeah, 116 different list actions. Okay, so I warned you, EC2 is the pathologically complex or large list of actions. But when I'm enumerating these actions here in my mental model, I don't care if it's EC2 or not. AWS is just made up of these actions, okay? And I think it's important to think about it that way rather than necessarily think service to service. The actions are the atoms of activity in AWS. And then resources are particular instances that you can talk to. And I don't just mean EC2 instances. I mean things like S3 buckets, S3 objects. It's the things with arms on them, the stuff. So, Lambda functions that are instantiated. So I'll put an EC2 here. I'll put an S3 here. Okay. So I normally ask this question when I'm teaching and we have an audience, but since today Drew and I are flying a duo, I'm just going to tell you these vertical lines are the default AWS policies for principals talking to actions and actions hitting resources. And those are deny. So AWS by default denies everything. No principal can talk to any action. No action can refer to any resource out of the box, okay? This is important because the mental model for IAM should be the holes that you're poking through that deny everything policy set that's applied at all layers. So let's say, for example, I'll show you an example here of, this is just straight out of the AWS docs. It's a super simple IAM policy, what it's designed to do. Well, let's talk through the topology and map it to our mental model first. So here we've got, which version we're using of the API, et cetera. And our statement is to create an allow effect. So these are allowances, all right? These are things that are holes through the denial, right? Through the deny everything. And you can see right here, action, right? Just like actions. And so that's where we're going to list the actions that we're talking about in this policy, right? And then here, resource. We're going to list the resources that we're talking about to this. Now, this one has a condition in it. You'll see a lot of these. This condition is, I put bar here, but you would put the instance ID of an EC2 instance if you wanted this policy to only apply to a single EC2 instance. I kind of regret that they have this in their examples because personally, I think this is a bad way to go, to map individual IAM policies to particular resources out there, because you can imagine if you have, a lot of our customers have thousands and thousands or tens of thousands or even hundreds of thousands of resources, hundreds of thousands in many cases. You don't want a policy for each one of those things. There are better ways to do that. I'll get to that in a little bit. But what this one is doing is it's saying these actions, just two, EC2 attach volume and detach volume. So it's just attaching and detaching EBS volumes against these resource types, the volume and the instance. So the resources there are the EC2 volume and the EC2 instance, or the EBS volume and the EC2 instance, although both live inside of EC2 from a service topology perspective. And then they're with the condition, they're choking it down to a particular arm. But the reason I wanted to show you that is that this mapping I'm giving you really is accurate to exactly how AWS thinks about this and how you need to think about it. So what were those? Those were, I got to remind myself, attach and detach volume. So we'll say here, attach, I'll just be shorthand, and detach volumes. So what we've effectively done by allowing that, and here we have a particular ARN on this, I think we called it bar. So that's EC2 instance called bar. So we've opened it up over here. So what that is allowing, we've poked holes through the deny wall, right, to the actions. And then we've poked holes through this secondary deny wall to bars, EC2 instance, and its attached EBS volume set. Right? So that's the basics of what we're doing with IAM, is opening holes and to some degree constraining them to get through these default denials. All right. I want to introduce another aspect of this, though, which is the process you might use to decide which IAM policies to either use or create. And I'm going to start by saying, generally speaking, you should try to avoid creating IAM policies if you can. If you are managing IAM policies, you are managing code. And code is always a liability. I write code for a living. Well, I don't anymore. But I've spent my career writing code for a living. And every line of code that you put on your own head to manage is actually something that you forevermore have to maintain. So for example, here, what if this instance ARN changes because a new instance is instantiated to perform the function that the old instance was doing? Well, now you have to go in and modify this policy, right? You don't want to do that if you can avoid it. AWS packages with every AWS account approximately 700 AWS managed policies. That should give you a clue about how easy it is to proliferate IAM policies. If AWS themselves have had to package 700 of them or more, it's really easy for this to get out of hand. And it has to do with the fundamental architecture that I won't go into of how AWS is built. But the nice thing about that is there's probably a policy in here that you can use for most purposes without writing your own, and you should start there. That becomes its whole own exercise in accumulating knowledge, right? There's no mental model that will help you navigate through 700 of these, but there's a lot of stuff in here. The other nice thing it gives you, though, and I'm going to pull one I have never looked at before, and hopefully I'll learn something by doing that. But this is a tutorial on how to write IAM policies that are, from the people who wrote IAM. So let's just look at the certificate manager read only. So we'll drill in here real quick. All right, again, it's a simple one. Let's just grab it and throw it over in the code editor where we can make the text a little bigger. So here, we're calling the version of IAM. We're saying allow ACM describe cert, list cert, get cert, list tags for cert. Okay, you notice there's no stars in here. These have some stars in them, but they are really constrained by this condition. But here the resource is star, in other words, any resource, but only those actions. Stars and actions are dangerous. All right, stars and they're dangerous for a number of reasons. One is that as AWS evolves a service, what a star means in terms of actions, like EC2 did not start out with 400 actions. But if you had a IAM policy that said star to IAM actions, every time they add a new action type, your policy inherits that type. And you probably aren't keeping up daily to make sure that those things are, safe and secure. And by the way, the bad guys are scanning every few minutes to see if you've screwed up. So stars are really dangerous in actions. Even substars like list star can be quite dangerous. Okay. So I want to propose, that was a little tour of the waterfront of how to think about actions and resources. There are lots of mechanisms in IAM and AWS policy in general to help you with this. But to do that, you need the mental model, you need to understand what you're doing, and then you need a process to validate what you're doing. And I'm going to propose one to you here. All right, let's get rid of my extra long lines, and I'm going to just use a new section of the whiteboard to talk about process. So, step one, need IAM permissions. And my computer's being slow today. So if you need IAM permissions, the first thing I would do is say, is there an AWS managed policy that will work for what I want to do? And if the answer is yes, then use it. Okay. If the answer is no, then you're going to need to write one. I would start with an AWS managed policy as an example, rather than something random pulled down from the internet, if I could. So I'm going to write one. Once I've written it, though, I need to, well, even as I'm writing it, the first thing I should be thinking about is really limiting actions. And that means learning what actions are really needed for the use case. Okay, and that actually turns out to be something where you're going to be, if you're a developer, you need to be thinking about that carefully as you're writing your code. What pieces of that API, don't be lazy and say, well, I'm just going to give myself S3 star and I'll sort it out later. No, as you're writing your program, keep a list of exactly which actions you're using in that program, whether it's going to be hosted on a Lambda function, a container, whatever, it doesn't matter. Keep a list, if we're talking about IAM for programmatic access, of which actions are needed so that you can have the least permissive policy in terms of actions, okay? But from there, we have to do some more. So we also want to limit the resources. Right, that might not actually be in your IAM policy. There are other ways to do that, like ABAC, which is probably beyond the scope of this particular session, but it's attribute-based access control. So instead of you having to hard code ARNs into your IAM policy, you can scope the activity of the principals who have that policy based on tagging. And that's a better way to go than actually writing it into your policy in code. You're going to test that, right? You're going to test it once you've got it for function, right? Can your program that's using this IAM policy do its job? Or is the policy too restrictive, right? There's a lot being said right now in the industry about doing the kind of analysis of policies like, do you have permissions that aren't being used? And that's fine, but it doesn't do that much for you. You should be able to write policies. You should have enough knowledge of your system to write policies that are not overly permissive up front. And yes, I'm saying you should do hard work. That's true. The false sense of security that those kinds of analyzers give you is that if you're only using, if you only have permission to actual actions and resources you need, that you're safe. And that's simply not true. It's not true at all. Most breaches don't occur because you have overly permissive IAM policies with unused permissions. It's because you've architected things in a way where dangerous permissions are in use, right? And those analyzers won't help you at all with that. So you really need the fourth step here to be analyze for security. That's what we do for a living at Fugue. So that's why I'm emphatic about it, because we save people from being hacked. And if you don't use something like this, you might well get hacked. We do have a completely free version that this is not going to be a product pitch. I'm going to keep talking about a process, but we're the only thing I know of that actually does this thoroughly and for free for IAM. So I'm talking about us a little bit there. But the kind of thing I mean here is this kind of a scenario. So this is our console. We also have a CLI and an API, but I want to call your attention to this one right here. IAM roles. So I'm showing here a console showing failures against what we call Fugue Best Practices. These are a collection of analyses of your environment based on our reconstruction of real attacks. This one is based on what we know from the Justice Department filings from the Capital One breach. And then we build in rules to tell you, are you exposing yourself in the way that victim was exposed in this Fugue Best Practices collection? So here we're saying IAM roles attached to EC2 instance profiles should not allow broad list actions for S3. Well, who cares? It's a list, right? It turns out that if you have an IAM policy that's being used by a human administrative user, they're going to need S3 list, okay? But if you have an EC2 instance or a container or Lambda running that's going and listing S3, if a bad guy gets their hands on the credentials to that through any of a number of means that are kind of, again, we can't go into too much detail, but the Thinking Like a Hacker Masterclass, I'm going to be showing you how to do this. If they get their hands on it, well, now they've learned your entire S3 topology. And they can perform commands like sync that require list. So that should never be in your compute infrastructure. And that brings up an interesting point, okay? That's why this becomes a cycle, a process. If your app dev folks have gone and written an application where the compute instances need access to listing S3, at some point you need to say, and hopefully it's you who are writing that code who are also looking at this, right? Hopefully it's you who are writing that code that are saying, you know, I need to make sure this is truly safe and secure myself in an automated way prior to getting automated feedback prior to putting it out in the wild or having a security team find it. But whoever you are, that should tell you to change the architecture of the program. You should not have a program running in AWS that uses S3 list. You should find those keys somewhere else, like in a database. Why? Because those are separate permissions. Why? Because the bad guy can't then do a sync command and steal all your data before you know it. So it's important when you're crafting IAM roles and policies to not just think, well, am I using all of these actions against all of these resources, but should I be? And what if someone else could? What could they do? Okay. So let's go back into the IAM management console. Well, actually, Drew, we're pretty far in here. Why don't we field a couple of our recorded questions?
Sure. We did have a couple that I think are relevant to some stuff you were talking about a little earlier about kind of analyzing your security posture of IAM. There were some questions about open source tools for analyzing IAM. There's the AWS IAM Analyzer, I believe is what it's called.
Yeah, so what AWS IAM Analyzer is going to tell you, and that's kind of what I was referring to, it's going to tell you if you have policies where you're not using all of the actions, but that actually doesn't help you I mean, that's a good thing to know and you should get rid of those, okay? I'm not saying it's not a value, it is a value, but it is very incomplete in terms of understanding what risks you're exposing yourself to. Because in my example that I gave of having S3 list permissions that are mapped via a role association to a compute instance, well, that's getting used. It's okay. No, it's actually not. It's very dangerous. Similarly, another one I want to point out that's extraordinarily dangerous is in EC2. Let's see here. In EC2, let's create a policy. We'll create an EC2 policy. And I think it's a write permission somewhere in here. Boy, I'm not going to find it right now, but because I don't recall the first character. You see how many there are of these. The ability to remap IAM role associations is actually, in other words, change your IAM policy, is actually part of the EC2 API, not the IAM API. You definitely don't want that one in your infrastructure. As far as open source tools, the only things I've seen, and I don't know everything. I mean, Fugue is, we have a bunch of open source stuff out there, so you can use our open source tools. We also have a SaaS with a completely free forever version that does this, level of analysis. I haven't seen anything else that really interrogates IAM at the level that I think is super useful. There are tools out there that I've bumped across that will try different attack strategies against your infrastructure, but I'm just not aware of anything that will actually interrogate the running infrastructure and do an adequate analysis of IAM to make me feel safe, but they might exist.
Okay, we did have a number of questions about Fugue Developer, which I think maybe we can kind of just save for the end.
Yeah.
Into those. One of the questions, you've probably kind of addressed it to some extent. Many times I want to use AWS policy, but restrict to specific resources, i.e. not star. How can this be done?
Yeah, well, let's dig into that a little more, because that's really important. When we go back over here and we want to map to specific resources. So there are a few ways to do this, and it really depends on the resource type. So this is where AWS gets a little Byzantine. There's no consistent rule. So two things. I mentioned at the beginning, IAM is just one kind of AWS policy. The way to think about IAM is one piece of the big policy evaluation that goes on every action on every resource that's ever executed. Okay, that's how to think about AWS. Just a big pile of actions, a big pile of resources, and policy evaluation at several steps through a principal acting on a resource. Okay. Now, for example, in S3, we have resource policies as well. So you can called a bucket policy on an S3 bucket. So that individual S3 bucket, you can do things like say, only this CIDR block, or only this list of principals. So one way to do this is for the resource types that have resource policies that you can put on them like that, you might have an IAM role that says S3 star, but on your S3 buckets, based on the application they're in, you might have constraints at that bucket policy that determine whether or not that principal can act on that resource. So you can think of that as like opening gates and then closing them. Because if anything evaluates to deny, the call is denied. So that's one way. And by the way, on S3, you should do that on absolutely all of your buckets. You should have resource level bucket policies on all your buckets. Otherwise, you're just trusting whatever anyone ever in your organization put in IAM. And that's really bad, right? Nobody should be trusting anyone in this world we're in. We should all be architecting our pieces of the system to be as independently secure as possible from a logical perspective. There's another thing, and maybe we'll do a class on this if folks are interested, or a class that includes this, called attribute-based access controls, where you can put tags, special tags, on all your taggable objects, taggable resources, which are the vast majority of resource types in AWS now. And you can restrict based on those collections of tags. And so where this is super useful is, let's say you've got an IAM policy for developers, but like some of our customers have hundreds of development teams and thousands of developers. Well, you really only want the developer team A to see team A's resources, and developer team B to see team B's resources, but not A's, and vice versa. So the way you can do this is by tagging all of those resources to that team or application or whatever you want, and then using the attribute-based access control, the same IAM policy for developers used by team A and team B, but the attribute-based access control only allows team A to see team A's stuff and team B to see team B's stuff. So I hope that that answers the question. But the one thing not to do, except in, you know, I can't think of a case where I would do this. You might come up with one that's valid. I'm not a judge here. I'm trying to impart some knowledge. I would be very hesitant to do what AWS did in this example here and like put an ARN in an IAM policy, because I just know that I'm going to end up with a proliferation of IAM policies with different ARNs in them, or some goofy way to like have a separate document that I've got to manage. Or and by the way, proliferation of resources on cloud and not maintaining them effectively because there are too many is probably the #1 attack vector. You losing control of your plant, right, of the boundaries of your configurations is really what hackers love, because you'll forget stuff and they'll find it and they'll exploit it. So I would avoid doing this, and I wish they'd take it out of their examples. Any other questions? Otherwise, I think we're kind of coming up on the top of the hour. I might go back to some slides and take us out.
Yeah, I guess there's two more. Are there any specific IAM changes we should be monitoring for? Like what kind of things should set off our alarm bells? I think.
Oh, yeah. Oh, yes, there are. So again, I'm going to go back to Fugue, because one of the things we do is we will track for any kind of change to your configuration. So Fugue will first will examine, you know, whether things are safe on a set of rules and visualize all that for you. But then what we're also going to do is notice if anything changes over time. And this is one of my demo environments that doesn't change much. But if we go to all time, we should find some stuff in here. So let's just look at modifieds. And I know I've got some in here that are illustrative that include. Yeah, so so this kind of thing I would really look for. I would immediately look at somebody changing the content of an IAM policy, right? Because that's the other thing that folks don't often think about is you've written a policy, you're good, right? Well, no, there's an IAM permission that allows somebody to change the policy, right? So how are they changing it? Don't know. In this case, we're showing all the changes that have happened to that policy. So here it looks like, yeah, this one would light my hair on fire. Somebody added S3 star, where before it was just get account, public access, block, list jobs, and create jobs. Now it's everything. That one line is a massive security hole. So one thing to look for in change is any kind of modification of the policy document itself, and making sure you're aware of what that is. It might be that the other one I'm looking for is an add. Yeah, so this is another one, right? Anytime roles are being added, role policies are being added, and role policy attachments are being added, those things indicate that there are changes of mappings to existing policies that could be granting resources in your compute environment capabilities that they should not have. And that was actually a central part of some of the big breaches in recent years, where if I go look at this EC2 instance, for example, you can see it has an IAM instance profile and a role. So the role maps, the profile maps to the role maps to the policy. So this EC2 instance has IAM permissions. If I start changing these, who knows what it can do? So those are very, very scary kinds of drifts to see. And by the way, it's kind of hard to like pluck them out of CloudTrail. There's a whole lot of activity there. That's why we do that drift management. Everything I'm showing you here, by the way, is free forever at a small scale. Like, and to us, a small scale means like 1,500 AWS resources. So if you're a developer, it's probably more than enough. And just encourage you to use it for free. It'll tell you a lot about this stuff. Any other questions, Drew?
Yep. Somebody has to adhere to SOC 2, and they're curious if there's any kind of SOC 2 gaps when it comes to IAM vulnerabilities.
Oh, yeah. No compliance regime. I mean, we can, you know, at Fugue, we do like SOC 2, NIST, HIPAA, a dozen of them. All of them together won't tell you if you have that one particular vulnerability I showed you and others, right? Which I don't even remember where I put it, but there are all kinds of gaps in all of the compliance frameworks out there when it comes to understanding what's really safe and secure with IAM in your environment. All kinds of gaps. And I think it's largely because those compliance families were created pre-cloud and think more from a data center perspective. You know, that might be, yeah, here's the best practice one I was looking for. That might be why. Also, there tend to be like standards bodies over those, or organizations that move a little slowly. And so stuff like this one I showed you here, we had to go write our own outside. I mean, we do SOC 2, we do NIST probably more thoroughly than anyone else. But we had to write our own and put it in our own best practices because the compliance families are not keeping up with the hackers. So yeah, the fact that you are passing a SOC 2 audit does not mean you are safe. It means you pass the SOC 2 audit. Those are different but related things.
Awesome. And there was one other question about Fugue Developer, which was, does it give you kind of an audit trail for auditors?
Yeah, it does. You can, so what Fugue's going to do is go examine all of your infrastructure. You can compare it to different compliance families. You can visualize it, and then you can tell it how often to do that. Default is daily. And then that keeps a complete mapping of everything you have in cloud forever, and you can extract it via an API or via a data dump out of the console, however you want. But yeah, we will give you your complete history, both from a configuration and a compliance perspective against you know, whatever compliance families. I think the free version does CIS. CIS and Fugue Best Practices. Paid versions will include, you know, NIST and SOC 2 and HIPAA and GDPR and all that good stuff. So.
Awesome. Yeah, I think that covers all the questions that we got.
All right. Well, I'm going to go back here to PowerPoint somewhere. Where are you? There you are. And we'll go to the last slide. And this was much less fun than live, but I hope it's helpful. And I look forward to seeing you all. I'll have more nerdy backgrounds for you to guess for prizes next time. And I'll turn it back over to Drew to take us out. Thanks for your time.
Yeah, thanks, Josh. And thanks everybody for checking this out. Again, definitely love doing these live more than taped. So that's our default. You know, definitely check us out for Thinking Like a Hacker on September 10th. And then we've got kind of this growing library of on-demand masterclass sessions for you to watch, fugue.co/masterclass. And with that, let's shut it down. Thanks, Josh.
Thanks, Drew.
See you next time.
See ya.